I, Huzaiza Farheen, welcome you to Republic Tutorials. Get ready to expand your knowledge with this captivating study material. Hello everyone. In this video, let us solve the most exciting problems of Exercise 11.4 of chapter Trigonometry. The first question is, evaluate the following. Here it is given that 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. We need to evaluate the value of this one. So what we are doing here is we are converting this tan theta in terms of sin and cos. We are writing tan in terms of sin and cos. As you can see, each of them are written in terms of sin and cos. So whatever we are using in a problem, whatever the formulae or theorems or whatever the statements we are using, that we have to mention it to the right. Here I have mentioned using the red color, as you can see. So 1 as it is, so 1 can be written as 1 upon 1, and then we have sin tan theta. So we can write tan theta as sin theta by cos theta. So tan theta is written as sin theta by cos theta. As we know, secant theta is the inverse of cos, so we can write secant theta as 1 by cos theta plus 1 by cos theta. Again, coming to the next bracket, 1 can be written as 1 upon 1. If there is nothing in the denominator, means we have 1, plus cot theta can be written as cos theta by sin theta. That also I have mentioned here. Then minus cosecant theta can be written as 1 by sin, because inverse of cosecant is sin. So cosecant theta can be written as 1 upon sin theta. Now we have, as you observe here, for both within this bracket there are 3 terms, 1, 2 and 3. 2 of the terms have the same denominator, that is cos theta. So we are changing the denominator of the first term also as cos theta. How can we do that? We are multiplying here both numerator and denominator with cos theta. Cos theta into 1 upon cos theta into 1 plus sin theta by cos theta plus 1 by cos theta. Now we have all the denominators as cos theta. Similarly, in the next bracket we have sin theta as the denominator of the second and the third terms. So we are converting the first term in such a manner that it has sin theta in the denominator. For that we need to multiply and divide the first term with sin theta into 1 by sin theta into 1. Now you can see that the denominators of the second bracket are all sin thetas. So when you have the same denominator as we do in numbers with the numbers, so when we have the same denominator, we write it the common denominator once, and then whatever is there in the numerator we write as it is. So cos theta into 1 is cos theta, plus as it is sin theta, then plus, then 1. Here also we have sin theta as the common denominator. So we are writing it once, then we will write the numerator as it is. Sin theta into 1 is sin theta plus as it is, and then cos theta minus 1. So what did we do? We wrote the denominator once, and then whatever is there in the numerator all together we have written along with the signs. Now if you observe this, the first 2 terms are sin theta plus cos theta. Here in this bracket also we have sin theta plus cos theta, and the second term, and the third term is 1 here. Here also we have 1. Now if you closely observe, it is in the form of a plus b. This one, this is in the form of, if you consider this entire sin theta plus cos theta as a and 1 as b, here also if we consider sin theta plus cos theta as a and 1 as b, it is in the form of a plus b into a minus b. Here a plus b into a minus b can be written as a square minus b square. Now if you observe one thing, this is actually a fraction. The sin theta plus cos theta plus 1 is the numerator and this is the denominator. Here this entire thing is the numerator and this is the denominator. When we have 2 fractions, what is the sign between them? The sign between them is multiplication, because they are in bracket, it means the sign between them is multiplication. When we have 2 fractions multiplying, then we multiply numerator with numerator and denominator with denominator. So we say a, this completely we are taking it as a plus b into a minus b. So, we can write it as a square minus b square. What is our a here? Sin theta plus cos theta is our a. So, sin theta plus cos theta whole square, this is nothing but a square minus b is 1 square, and then in the denominator we, what did we say? Numerator into numerator. Upon doing that we got this one. Then denominator into denominator, cos theta into sin theta, we get it as cos theta sin theta or sin theta cos theta. Order does not matter when it comes to multiplication. Then this sin theta plus cos theta whole square is in the form of a plus b whole square. It is in the form of a plus b whole square. What is the expansion of a plus b whole square? It can be written as a square plus 2ab plus b square. So, what is our a here? Sin theta is a. So, a square is sin square theta. It should not be written as sin theta square, that is a wrong notation. It is sin square theta. A square is sin square theta. If I take this as a, here we consider sin theta as a and cos theta as b. A square means sin square theta plus 2 into a into b, 2 into sin theta into cos theta, plus b square is cos square theta. It is not cos theta square, we have to write cos square theta. Then minus 1 square is 1 itself, and in the denominator we have, if we rearrange this, sin square theta, then I am writing here plus cos square theta, then plus 2 into sin theta into cos theta minus 1. But we know the identity that sin square theta plus cos square theta is equals to 1. So, instead of sin square theta plus cos square theta, we can write it as 1 plus 2 into sin theta into cos theta as it is, then minus 1. Plus 1 and minus 1 will get cancelled. We will be left with 2 sin theta cos theta upon sin theta into cos theta. Sin theta and sin theta will be cancelled and cos theta and cos theta will be cancelled, and the value left will be 2. Hence, the value of 1 plus tan theta plus cos secant theta into 1 plus cot theta minus cosecant theta is 2. Coming to the next problem, we have the question as sin theta plus cos theta whole square plus sin theta minus cos theta whole square. We need to evaluate the value of this. Again, if you observe closely, this sin theta plus cos theta whole square is in the form of a plus b whole square. It is in the form of a plus b whole square. So, sin theta will be a and cos theta will be b. So, what is the expansion of a plus b whole square? A square plus 2ab plus b square. We have sin theta as a. So, a square will be sin square theta plus 2 into a into b will be 2 into sin theta into cos theta plus b square is nothing but cos square theta. I repeat, it is not cos theta square, it is cos square theta. Then similarly, the second bracket, as you can see, plus sign as it is, it is in the form of a minus b whole square, and the expansion of a minus b whole square is a square minus 2ab plus b square. So, what is our a here? Sin theta. So, a square will be sin square theta minus 2ab is nothing but minus 2 sin theta into cos theta, then plus b square. B is nothing but cos theta, cos square theta. B square is cos square theta. As we have plus 2 sin theta cos theta and here minus 2 sin theta cos theta, these two will get cancelled, same term with opposite sign. Then what we are left with? Sin square theta plus sin square theta. As we have x plus x, that will be 2x. Similarly, sin square theta plus sin square theta will be 2 sin square theta, and cos square theta plus cos square theta will be 2 cos square theta. Can we take 2 common here? Of course. So, 2 when we take common, here the first term is left with only sin square theta plus this is we have taken outside and cos square theta. What do we do when we are taking common? We write the number number or term whatever we are taking as common variable or number or anything, and then we will start immediately the bracket, means it is what is the operation between this bracket and this 2, that is multiplication, and whatever the values or variables or whatever the things that are left in the bracket, that we will write. So, when we take out 2, what is left here? Sin square theta, plus when we take out 2, what is left here? Cos square theta. But we know from the identity that sin square theta plus cos square theta value is 1. So, we can write instead of this sin square theta plus cos square theta as 1. So, 2 into 1 is nothing but 2. I hope you understood. For the next one, the third question is, this is the third bit of the first question itself. Again, this is a question from 11.4, first bit, third one. We need to evaluate the value of secant square theta minus 1 into cosecant square theta minus 1. But we know the identity that secant square theta minus tan square theta value is 1. So, from this we can derive the value of tan square theta. What did we do here? We transpose this minus tan square theta, so it becomes tan square theta plus tan square theta, and we have transposed this 1 to the LHS, it became minus 1, plus 1 became minus 1. So, secant square theta minus 1 is equals to tan square theta. So, instead of secant square theta, here we can write it as tan square theta. Similarly, we have another identity, that is cosecant square theta minus cot square theta is equals to 1. Because we need cosecant square theta minus 1 value, what we are doing? We are bringing this 1 to LHS, so it becomes minus 1, and we are taking this cot square theta to the RHS, so that it becomes cot plus cot square. So, we have the cosecant square theta minus 1 value here, we got it as cot square theta. So, we got secant square theta minus 1 as tan square theta and cosecant square theta minus 1 as cot square theta. As we know, the tan and cot are the inverses of each other. So, cot theta can be written as 1 by tan theta. We are writing tan square theta as it is into cot square theta can be written as 1 by tan square theta. Numerator and denominator can be cancelled. So, when can it be cancelled? Because the operation over here is into multiplication. So, we can cancel the numerator and denominator. So, we will be left with the answer 1. Hence, the value of secant square theta minus 1 secant square theta minus 1 into cosecant square theta minus 1 is 1. Now, moving to the next question, it is, we have show that cosecant theta minus cot theta is equals to cosecant theta minus cot square theta is equals to 1 minus cos theta by 1 plus cos theta. For this, what we will do? We will take LHS first. What is LHS? Cosecant theta minus cot theta whole square is the LHS. This is the LHS. Let us mention it here. LHS is cosecant theta minus cot theta whole square. Now, what we are doing? We are writing it in terms of sin and cos. So, cosecant theta can be written as 1 by sin theta, because sin theta and cosecant theta are inverses of each other, and cot theta can be written as cos theta by sin theta when written in terms of sin and cos. So, cosecant theta will become 1 by sin theta minus this will become cos theta by sin theta. Do we have the same denominator? Yes. So, we will write the same denominator common, that is once we will write it, because both the fractions have the same denominator, we will write it once, and the numerator will be written as it is 1 minus cos theta. Now, we know the laws of exponent that a by b whole to the power of m is nothing but a to the power of m by b to the power of m. What does it mean? If you have whole bracket and you have the power something, that power belongs to both the numerator as well as denominator. So, this can be written as a to the power of m upon b to the power of m. So, we have this whole square. So, this square belongs to both numerator as well as denominator. So, 1 minus cos theta whole square, we are applying it separately upon sin square theta. So, then can we write a into a as a square as a into a? See, for every statement, for every step I am taking, whatever the statement I am using, whatever the formula, whatever the law we are using, we are writing it on the right side. Now, it is in the form of 1 minus cos theta whole square is nothing but it is in the form of a square. A square can be written as a into a, right? So, we can write 1 minus cos theta whole square as 1 minus cos theta into 1 minus cos theta, and here we have sin square theta, right? So, this sin square theta, the value of it can be obtained from the identity, that is sin square theta plus cos square theta is equals to 1. When we transpose this cos square theta, it will become sin square theta is equals to 1 plus cos square theta will become minus cos square theta. So, we can write the sin square theta value as 1 minus cos square theta. Here we have sin square theta. So, we are writing the value of it as 1 minus cos square theta. So, can we write 1 as 1 square? Of course. So, here we have 1 minus cos theta into 1 minus cos theta by, now if you observe, this 1 square minus cos square theta is in the form of a square minus b square. So, a square minus b square can be written as a plus b into a minus b, right. So, we are writing the denominator 1 square minus cos square theta as 1 plus cos theta into 1 minus cos theta, because we have the same term both in the numerator and denominator, and what is the operation between them? Multiplication. So, we can cancel this. So, we are left with 1 minus cos theta by 1 plus cos theta. This is the required RHS, as you can see. This is the required RHS, that is equals to RHS. Okay. Moving to our next question. The third question, show that under root 1 plus sin a by 1 minus sin a value is equal to secant a plus tan a, where theta value lies between 0 and 90 degrees. So, in order to solve this, let us again take LHS. What is our LHS? LHS is under root 1 plus sin a by 1 minus sin a. Now, how shall we solve this? Let us multiply and divide by the conjugate of 1 minus sin a. That is nothing but, as we did last year in grade 9, the rationalizing, we just change the sign of it. Similarly, what we are doing? We are multiplying the numerator and denominator with, here actually it is under root 1 plus sin a. So, that is why we can take it inside the root. So, what we are doing? 1 plus sin a by 1 minus sin a, right. So, we are multiplying and dividing with, we are just writing the opposite sign of this. So, 1 minus sin a we have in the denominator, we are looking at the denominator, okay. So, we will write 1 plus sin a by 1 plus sin a. The same thing we are multiplying both in numerator and denominator. Now, these are the two fractions and we have the multiplication sign in between. So, numerator into numerator and denominator into denominator will do. 1 plus sin a into 1 plus sin a, nothing but it is just like a into a, the same term, a into this is a, it will be a square. So, we can write it as 1 plus sin a whole square. Now the denominator is in the form of a minus b into a plus b. So this identity says that a plus b into a minus b value is a square minus b square. What is a here? 1. 1 square minus b is sin a, sin square a square minus b square. Now we know that under root ab, if we have under root ab, this root can be applied separately both to the numerator as well as denominator, this numerator and denominator. So under root ab can be written as root a into root b. So we are applying this root both to the numerator as well as denominator. Under root 1 plus sin a whole square by under root 1 minus sin square a. The square and square root can be cancelled. Again we will be using the identity sin square theta plus cos square theta is equals to 1. Now I need to find the value of 1 minus sin square theta. So what can we do? We will just transpose this sin square theta. So cos square theta is equals to 1 as it is minus sin square theta. Whenever we are transposing, whatever the left out things are there on the LHS, we will write it first, is equals to, and what is there on the RHS, that we will write first. So we have 1 plus sign, we have here sin plus sin square theta is it is. You have to look at the sign before the number or term whatever we have. So it is plus sin square theta, when transposed it will become minus sin square theta. So 1 minus sin square theta value can be written as cos square theta. The square and square root will again get cancelled because the denominator belongs to each of the terms in the numerator. This can be separately written as 1 by cos a plus sin a by cos a. We know that 1 by cos is the inverse of secant. So 1 by cos will be secant a plus sin theta by cos theta value is tan theta. So sin a by cos a value is tan a. So this is the required RHS is equals to RHS. Now moving to our next question, question number 4. This is also one of the interesting questions. We need to show that 1 minus tan square a by cot square a minus 1 is equals to tan square a. So let us convert this, let us take the LHS and express it as in terms of sin and cos. So we know tan theta is equals to sin theta by cos theta and cot theta is equals to the inverse of it, that is cos theta by sin theta. Let us substitute the value of that. 1 minus tan theta can be written as sin a by cos a whole square by cot theta can be written as cos a by sin a whole square minus 1. So this square belongs both to the numerator and denominator, as we have a to the power ab whole to the power of m is equals to a to the power of m by b to the power of m. So we can apply it separately. 1 minus sin square a by cos square a. What did we do here? Applied the square both to the numerator as well as denominator. Then coming to the denominator, cos square a by sin square a minus 1. Now if we take the LCM, we have cos square here, or you can just do as we have done in the previous one. In order to make the common denominator, we are multiplying here cos square a both in the numerator as well as in the denominator, right. Then here also, because to make the denominator sin square a, we will multiply with sin square a both in the numerator and the denominator. Now we have the common denominator, that is cos square a, right, and we will write it once and the numerator will be written as it is cos square a minus sin as it is sin square a by, here we have sin square theta, sin square a it is, okay, sin square a. Sin square a as common, so we will write the common ones, that is sin square a, then numerator we have cos square a minus 1 into sin square theta is nothing but sin square a. 1 into sin square a is sin square a. Now cos square a minus sin square a by cos square a into whatever the fraction is there in the denominator, what will happen to that? We will get a multiplication sign here and we will write the inverse of it, means denominator will become numerator and numerator will become denominator. As you can see, a by b upon c by d can be written as a by b into d by c. The denominator of denominator will become numerator. Simply whatever is there in the denominator we will write the reciprocal of it. So here we have c by d, we will write d by c, and what will be the sign in between them? Multiplication. The same thing we have done. We have written the numerator as it is, then multiplied by the inverse of this one, that is sin square a by cos square a minus sin square a. This and this will get cancelled, so we are left with, so 1 into, this is 1 and 1, right? 1 into sin square a is sin square a by 1 into cos square a is cos square a. So as we can write a by b whole to the power of m as a to the power of m by b to the power of m, similarly we can write a to the power of m by b to the power of m as a by b whole to the power of m. So this square we have both in the numerator and denominator, we can take it out as common, that is whole square. We will write sin a by cos a whole square, because we know that sin a by cos a is tan a whole square. We can write tan a whole square, but when we are writing without bracket we should write tan square a, which is the required RHS. Now moving to the next question, question number 5 of the same exercise 11.4 of trigonometry. We need to show that 1 by cos theta minus cos theta is equals to tan theta into secant theta. It is a very simple question. So let us again take LHS. So what is our LHS? 1 by cos theta minus cos theta. So for this cos theta, if there is no denominator, what is the denominator we have? 1. So 1 by cos theta minus cos theta by 1. So how to take the LCM? We will just multiply the denominators of both the terms, that is 1 into cos theta is cos theta, and we are cross multiplying the numerator here. In order to get the numerator we are just cross multiplying. 1 into 1 is 1, then minus as it is cos theta into cos theta is cos square theta. As we know from the identity, sin square theta plus cos square theta is equals to 1. When we transpose cos square theta to the RHS, we will get sin square theta is equals to 1 minus cos square theta, right. So 1 minus cos square theta can be written as sin square theta. So I am replacing this 1 minus cos square theta with sin square theta upon cos theta. It is actually a square, right. So a square can be written as a into a, that is sin theta into sin theta. Sin square theta can be written as sin theta into sin theta by cos theta. Now sin theta by cos theta value we have it as tan theta into sin theta, which is the required RHS. Is it not simple? Yes, it is. Now moving to the next question. Here in this question it is given that secant a into 1 minus sin a into secant a plus tan a. We need to simplify this. So what is given? Simplify. We need to write it in the simplest form. So let us apply the distributive property for the first two secant a and the first bracket, okay, secant a into 1 minus sin a. So how do we apply? We will multiply this first term with the first term of the bracket, that is secant a into 1 minus, again we will multiply the same with the second term of the bracket. So secant a into 1 is secant a minus See, when we are multiplying, we will multiply, this is we do not have here coefficients, but usually if you observe, when you have 2x into 4x minus 1, suppose. So, how do we multiply? The order is, first we have to multiply the signs, then coefficients, means the coefficients are the numbers that are multiplying the variables, then we have to multiply with the variable. That is, plus into plus is plus, 2 into 4 is 8, x into x is x square. Then plus into minus is minus, 2 into 1 is 2, and x into nothing is again x. So, similarly, plus into plus is plus, secant a into 1 is secant a, then plus into minus is minus, secant a into sin a is secant a into sin a. Then we have the second bracket as it is. Now, we can write secant a minus secant as 1 by cos, right. So, sin a, 1 into sin a is nothing but sin a by cos a, because why did we write cos down? Because secant a is nothing but 1 by cos a. So, 1 when multiplied with sin a, it will get back sin a itself. So, we are not writing that. So, sin a by cos a into secant a plus tan a. We know that sin a by cos a value is tan a. So, secant a minus tan a, sin a by cos a we got it as tan a into secant a plus tan a. If you observe closely, it is in the form of a minus b and a plus b. So, what is our a here? Secant a, and what is our b here? Tan a. So, this can be written as a plus b into a minus b can be written as a square minus b square. So, secant square minus tan square, but we already have the identity that secant square theta minus tan square theta is 1. So, secant square a minus tan square a can be written as 1. This is the required answer. In this video, we have one more question, that is question number 7. The remaining questions I will be explaining in the next video. So, what is the 7th question? Prove that sin a plus cosecant a whole square plus cos a plus secant a whole square is equals to 7 plus tan square a plus cot square a. For this kind of questions, we will take LHS. So, what is LHS? Sin square a plus cos square a, if you can observe, sin square a plus cos square a, sin a plus cos a whole square plus cos a plus secant a whole square. This is the LHS. So, if you observe, sin a plus cos a whole square is in the form of a plus b whole square. What is the expansion of a plus b whole square? A square plus 2ab plus b square. So, what is our a here? Sin a, and what is our b here? Cosecant a. So, a square will be sin a square plus 2 into a is sin a and b is cosecant a, 2ab plus b square is cosecant square a. Then moving to the next bracket, we have plus, here the sign we have plus, so we will write down plus. Then again it is in the form of a plus b whole square, a square is cos square a, then 2ab is 2 into cos a into secant a plus b square is secant square a. Now, we have sin square a plus 2 into sin a into cosecant a is nothing but 1 by sin a plus cosecant square a plus cos square a we are writing as it is, then again plus 2 into cos a into secant a can be written as 1 by cos a. What did we do in this step? Just we wrote everything as it is, we converted this one, that is 2ab is there na. So, we converted this and this one. So, 2 sin a cosecant a is written as 1 by sin a. Every time you use it, you write it on your RHS, I mean to the right side in the bracket that you have used this formula or condition or statement whatever. Then plus cosecant square as it is, then we have cos square A plus 2 cos A into secant A we have written as 1 by cos A plus secant square A. The sine and sine will get cancelled, cos and cos will get cancelled. So, we have sine square A plus what we are doing, we are just rearranging. So, cos square A we can write because we have the identity sine square A plus cos square A, that is why we are writing together. Then plus 2 into 1 is nothing but 2. Then again we have one more 2 here. So, that 2 plus cosecant square A plus secant square A. Now, we have the identity sine square theta plus cos square theta is equals to 1. So, we can write sine square A plus cos square is equals to 1. 2 as it is and 2 as it is. Then we have cosecant square theta is equals to cosecant square theta minus cot square theta is equals to 1. From this we can derive the value of cosecant square theta, that is nothing but 1 plus cos square theta. When minus is transposed, it will become plus cot square theta. Then we have secant square theta minus tan square theta is equals to 1 as one more identity. From this we can calculate the value of secant square theta by transposing the value of tan square theta. Here it is minus tan square theta, when transposed it will become plus tan square theta. So, secant square theta is equals to 1 plus tan square theta. So, now coming back to our question. So, till here we have done. So, the cosecant square theta can be written as 1 plus cot square theta, that is what we have written here. Then we have secant square theta can be written as 1 plus tan square theta, that we have written. Let us add all the numbers. 1 plus 2 is 3, 3 plus 2 is 5, plus 1 6 and plus 1 7, and we have cot square theta plus tan square theta. This is nothing but our required RHS, as you can see.